So let's just review our objectives for our 3 days of training. Identify and describe the benefits, costs, and longevity of living shoreline projects for potential clients. Respond to client questions and concerns about different types of shoreline stabilization, including living shorelines. Understand the living shoreline permitting process for North Carolina. Conduct analyses of site factors to design living shoreline projects. Implement non-structural, such as grading and vegetation, and hybrid, such as structural and vegetation, living shoreline projects. Understand how to secure materials and determine equipment needs for living shoreline projects. Create business opportunities to monitor and maintain living shoreline projects post-construction. And provide instructions to property owners on basic maintenance and how to evaluate project success. So our agenda for today, first we will hear from Spencer Rogers with North Carolina Sea Grant. He'll walk us through how to do a desktop or computer office analysis of site factors. Then we'll hear from Laura Eddy with the Nature Conservancy. She's going to show us the Living Shoreline Explorer tool. Then Tracy Scrable from the North Carolina Coastal Federation will talk us through how to do a field analysis for a living shoreline project. We'll take a 10-minute break around 10:25 a.m. And then Tracy will get more in depth into site design options. After that, we'll hear from Tara McPherson with the Division of Coastal Management on how to permit these things. And we'll get you out of here by 12:15 p.m. So with that, I'm going to turn it over to Spencer.
Good morning, folks. My name is Spencer Rogers. I'm a coastal engineer geologist with North Carolina Sea Grant, and I'm going to pick up from last week's session. In your manual, that's the beginning of Module 2. We'll start on this morning. And the objectives of this module are to conduct desktop and field analysis of some of the site factors that you'll need to know in order to do the design work that comes in the later module. We're going to differentiate among some of the shoreline options on where they work and best and where they're probably not appropriate. And we're going to plan some design options based on site analysis and the appropriate application methods. We're going to try to separate the criteria for different permits that you will be hearing later in the session. Get through this. In your manual, there'll be a series of technical definitions. Many of you are already familiar with those, so I'm not going to go into the details, but you can back that up with the manual. So I'm going to introduce a section with Tracy and I and Laura on site analysis and design considerations. So there's some things we want to know about the shoreline that we have various ways to learn about. And first and most importantly is often is the shoreline eroding? What's the severity of that erosion? What's causing those? It could be storm waves, boat wakes, or stormwater runoff, for instance. And we're also looking at upland and nearshore slopes, that those have an important factor on how some of these options can be applied. The shoreline orientation relative to primary wind directions, the topography and bathymetry of the land and water can also be important. The existing bank and shoreline conditions are obviously very important, and we'll want to look at the information, particularly in the field for that, and the locations of any existing erosion control structures or other features that may be important, and to look at some of the habitats and shoreline erosion features. So what can we learn from the desktop and from on-site analysis? In the desktop, we can learn a lot from the field, but there are also some misleading things that may occur. For instance, if there's a recent storm, it may blur the long-term erosion issues on the problem and give you an overestimation of how severe the erosion is in the long term. Since most of these structures are going to be dealing with long-term erosion rather than the extreme events like recent hurricanes. And we're going to want to know what the wave exposure is. We're going to want to know some important information about the tides and tide ranges, and to some extent, the potential storm surge for the area. Well, first, let's look at the long-term erosion rates. That one way we can find out those details is to talk to the property owners. Do they have surveys on the ground when they purchased the property or when previous owners purchased? We can look at historical ground photography that they may have, but probably more likely and more useful in many cases is aerial imaging software like Google Earth Pro that I'll get to in just a minute. But there are many other sources of aerial photography that can be useful, including some from state and federal agencies. Well, a very important tool I find is Google Earth Pro. Google has changed the names of some of their products recently. Google Earth has been around for a good while. There's some mobile versions that don't offer some of these features, but the desktop computer version that I'm showing here is now called Google Earth Pro, and it's got some features that are very useful that we'll take a closer look at. From this, we can look at recent conditions, historical images back in time for a ways anyway, and we can use shoreline markers and measurement tools that are readily available from desktop use. Now, an important feature in Google Earth Pro is this this bar on the top, and particularly this clock on the top menu. So it's shown down in here. That clock, once you click it, turns on this slider below, and that allows you to cycle through a series of historical photographs rather than the first one that pops up, which is usually a recent clear sky photograph. So in this case, we can go back all the way to 1993 and look at historical images on this date. And an important reference is this bottom line imagery date, picking up down here, that gives you the exact date of when that photograph was flown, and that's important for using it in shoreline comparisons. Now, Google Earth overlays are not always perfect, but they're often pretty darn close. You need to check that when you go in and do measurements, but you can put in a push pin from the menu bar at the top, set this pin on an existing shoreline, and then go back in time on the slider to an earlier date. And we're going to go back to 1993 in this case. So you'll see the 1993, the push pin is still in place. We can look at the distance between the shoreline change over that period of time and use the menu bar up here to click on the ruler, and that will allow us to get a measurement of this distance between the two. So in this case, over the 22-year period, is 63 feet of difference, and that's about 3 feet per year. So this section of Morris Island, where we're going to do our field trip later, has got a healthy erosion rate down on the south end of that area. So this is a very useful tool that we can use in the desk without even looking at the field. And it also gives us the historical records that you can't always see in the field. So that's a pretty useful tool. Now from this, we're going to want to know what the open water fetch is. Fetch is the distance of open water where the waves can generate. We're going to want to know what the prominent and dominant storm wind directions are. And in some cases, we may want to look at wave heights, either from gauge measurements or wind speed predictions that I'll touch on. So here's an example of our Morris Island site where we just put a push pin. So if we look at the average fetch in this case, it's relatively small, less than half a mile. But if we look at the northeast and southwest directions, it's over a mile. So if our dominant wind directions like northeasters are coming in from that area, wind waves may be an important issue in looking at fetch. Now, in most cases, we're going to use fetch instead of actual wave design conditions, but those can be calculated from resources like this one by the Federal Highway Administration, known as HEC-11. But if you put in a fetch and a wind speed, you end up getting a wave height and period should you need that for design purposes. Tide conditions are very important. That's particularly necessary when you're looking at planting marshes or new marsh plantings. That the marshes that we commonly use have relatively narrow tide ranges that they prefer to grow in. The smooth cordgrass, for instance, you'll learn is likes a depth range of between mean high tide and mid tide. So it likes to get wet part of the day, but not all the day. And the tide conditions are also important for looking at some of the structural options we're using. They can keep the cost down, and they can make stronger structures if we properly set the elevations relative to the tide ranges locally. Now, the particular tide data we're going to want to look for is the mean high water line, the mean low water line, and the tide ranges. Now, there are many people or many groups will publish tide tables, but I find the most useful to use for these types of projects is NOAA's tides and currents. That's the basis for all the other tide records that you'll see. That everybody goes back to their predictions and reprint them more or less. So go back to the main source and you'll get the best information. The other advantage of going back to tides and currents is their primary stations um, offer not only the tide ranges for each of their areas. So in this case, we've got mean high water line, the upper range of where smooth cordgrass is going to row, the mean low water line on most days, and the tide range here, reference to mean sea level, is about the mid tide level in this particular plot. And you can change the datums for between these to set one when you want. This one is set for mean sea level, so we're half the tide range above and below the mean sea level. Now, the other important feature in this is that um, the tides are based on astronomical drivers, the sun and the moon and gravity, and they're the best predictions available, but they're not the local tide range because on any given day, there are significant wind and pressure components that are affecting what the actual water levels are. So in this particular day, there's actually a prediction down here that's a little above mean low water on that particular day, about 3/4 of a foot. But the actual low water that occurred on that day was way up at mean sea level, almost 2 feet above what was the average level for that. So if you're going out on the field and want to know what the conditions are, look for these NOAA tide gauges as close as you can find, and they'll give you a real-time prediction of what was there when you were there or what may be there when you're planning to go take a look. Now, the wind waves are only, and tides are only a part of the equation. You will learn more about boat wakes in many sheltered areas, like our case in Morris Island. It's relatively sheltered from wind wave fetches, but our major cause for concern in many cases is going to be boat wakes if navigation channels are placed nearby. So the fetch may not be the controlling factor. It may be the size of the boats, the speed of the boats in nearby channels. So you'll need to pay attention to that in your desktop analysis. Uh, Now, in addition, there are other extreme event predictions. The most common that you're going to run into are FEMA's 100 and 500-year storm surges on their flood insurance maps. But there are also storm records from the U.S. Geological Survey and other historical elevations from the Corps, FEMA, and emergency management. Now, in most cases, the structures and shoreline options you're going to be looking at today are going to be designed for long-term erosion and not the extreme events. But particularly if you've had an event nearby in recent years, that may be a factor that's driving what you see and what you observe on the field connections. And the manual has some desktop references that you can use to find out some of those informations. And with that, I'll turn it back over to Whitney.
Thank you, Spencer. We do have time for questions. If anyone has a question for Spencer, you can come off mute or put it in the chat box. All right, I'm not hearing any questions, so I'm going to pass it on to Laura Eddy. Laura's with the Nature Conservancy, and she's going to talk about the Living Shoreline sighting tool.
All right, great. Thanks so much, Whitney. And I'm just gonna take a second here, guys. All right, so good morning. Thanks for having me. And today I'm going to discuss and demo this new online tool, the Living Shorelines application. And this is the link at the bottom of the slide here that hopefully you can visit after the training. It helps users identify where the shoreline conditions, some of this technical site-based information are suitable for ensuring a successful living shoreline project. I would classify it as a quick screening tool that can help you determine like one aspect of what was just covered as far as the site's wave exposure or energy conditions. And it also provides some guidance on what those living shoreline design should be suitable for that location to stabilize the shoreline and address your potential erosion concerns. All right, so one caveat before we jump into this. Unfortunately, this is a new tool and the coverage is currently limited to Carteret and Onslow counties. So while it's limited, I really encourage you to please try to consult and use this tool if you do have a project or interest in these areas, because we can't expand the coverage if it's not used, and we would love to expand it. Certainly in these areas, it could be useful to consult before you invest a ton of time and energy in walking through some of this desktop site analysis for wave exposure, as this tool can provide some insight on that part of the analysis. And we're really interested in improving upon it, as like I said, maybe even potentially expanding it. So I encourage you to reach out to me. I'm always willing to talk to anybody interested in using these tools. And I also think that, in my perspective, it could help you kind of get a quick assessment of that homeowner's perspective of the erosion risk and kind of validate it against this quick scientific analysis that's baked into the tool's use here as far as the shoreline wave energy. Is that the major impact that's happening here before you go on site that would give you a quick screen? As well as determine the amount of protection this site might need. So it would enable you to kind of get that baseline feel before you invest a ton as far as needing to slow the erosional effects on the site. And I just want to point out here, remember, these are shorelines. We're not stopping erosion. We're just trying to slow or stabilize it because erosion is a natural process. It's something that we see along all our shorelines. Okay, so as far as background on the tool and to give you understanding and a level of knowledge and comfort of what went into it. This tool is based upon work by scientists Dr. Jenny Davis and Dr. Carolyn Curran from NOAA's Beaufort Lab on Pivers Island. And it brings in their research on shorelines in the southern Pamlico Sound and the New River Estuary into the streamlined regional analysis that's in the tool based upon that shoreline wave energy exposure. And the reason we know this is we know physical processes such as Spencer mentioned, boat and wind wave energy are really dictating where some of these natural solutions will be effective enough for a homeowner or customer's approval to stabilize that shoreline. And let's look at the side here. What we're kind of representing here in that lower left-hand corner is that very low energy areas, natural features are going to be successful and will work. But as wave energy increases, more and more structure is going to be needed. And as we move from that left corner to the right side, we're going to need more and more structure, and it's going to cost us more time and permitting. And so the reason that we're using this analysis and what kind of is baked into this is that scientists in these areas have documented that the width of the natural shoreline marshes is extensive, where we see wave energy below 300 joules per meter. So that's baked into the analysis, and it's based upon that research that they've seen in our area. But between that 300 and that 700 joules per meter, we can see success in these living shoreline projects that are hybrid and that have some structure. And so we're trying to give you those bounds in this quicker screening tool. And then above that, we're definitely going to need some structure. So to give you some more details of what's baked into the analysis the tool is based upon, we have 3 factors. We have wind wave energy, boat wake energy, and proximity to marsh. To go a little bit more into that, the wind wave energy is based upon NOAA's wave exposure model. That was used to determine the shoreline wind wave energy at 50-meter points along the shoreline. And this model uses bathymetry, or that contoured map bottom, adjusted by 1 meter to account for that tidal range that we see in this region. So that's baked in there. Also plugged into that model was the wind from a local station at Cape Lookout. And what they used was both direction, so that's attending to some of those criteria that Spencer covered, the speed, and what they utilized was the top 20% as far as intensity. So we're getting as far as the maximum exposure in those areas. And then the model generated waves as far as the size and frequency. And it measured the maximum shoreline wave energy at these 50-meter points. That was the first factor. The second factor they used was boat wake energy. So we know that boat wakes are making waves, and but as far as research has shown us that, that wake and that wave will only travel so far before it kind of peters out. And so they based their analysis and the indexing upon the distance of the shoreline point from those existing navigational channels. And they adjusted it according to, was it a recreational channel or commercial traffic, because the waves are generally different from those kind of vessels. The third factor, proximity to marsh. We know that if there's nearby marsh, it's going to indicate that there's suitable conditions for marsh vegetation to grow and survive. And that was also incorporated if it's within 100 meters. That was ranked in the suitability analysis. So all these things, don't worry about. If you don't remember, you can go to the tool. I'll show you where there's a methods link, and you can review all the information that the tool and the analysis is based upon. So the intent here is just to streamline some of this stuff that we're going to cover here and go through these steps to give you some of that information as far as wave height, water fetch, that's kind of baked in here with that model, and then analyze that relationship between all these factors to give you a map view of what might be suitable along the shoreline for a project. Let's go, and I'm going to skip ahead. I'm doing okay on time. I'm going to skip this, and I'm just going to go to a demo. This is not live, so just bear with me. You can certainly visit the tool afterwards and try it on your own. The website is down here at the bottom, and this is part of the Nature Conservancy's Coastal Resilience web mapping tool or platform. And it's a web-based tool, and it can be used in most browsers as far as Chrome, Firefox, and Safari. Not Internet Explorer. Internet Explorer is not well supported with this tool. If you visit the site, there is a bottom corner tour button down here on the left side that can show you some of those features, but I'll quickly run through what it does. It guides you through the left-hand side of the screen. You've got this yellow bar, and that's most of the functionality of the tool, or where the Living Shoreline Explorer app will be found. On the right-hand side of the screen here, we see there's an address bar similar to Google Maps. You can type in an address for your site, and the map will zoom to that location. We've got the imagery, the base map that you can pull down and change from street view to aerial. Also, you can see in this right-hand corner, it's kind of hard to see for me, but a little wrench. And in that icon, you'll get a pull-down menu that will demonstrate ability to measure, create a PDF map, or save and share a link. So these are all resources that are built into this tool. All right, now I'm gonna jump in and start showing you some of the functionality of this Living Shoreline app. All right, so imagine that we're interactively doing this, and you can see on the left-hand side of the screen, again, this yellow box, and that is the Living Shoreline application or tool like on your phone. And you click that, the home window will appear, this section where you've got information about the Living Shoreline Explorer. The map will change and you will zoom to Carteret County. Again, I'm sorry about the limitation, but please use the tool so we can expand it. You'll also notice here under this red line that there's a summary statistic. And as far as this tool, and it's based primarily just upon the wave exposure for the shoreline, it's saying a lot of the shoreline in Carteret County is actually suitable for some type of living shoreline project. You can also see now we have these 3 different color buttons of green, yellow, and orange. And that is showing the different living shoreline design types that might be suitable for that shoreline. And now I'm gonna jump to the next one.
Excuse me, Laura, you've got a 2-minute warning.
Okay, thank you. If you're unclear on what the suitability recommendation is, you can click these little question mark buttons, and an info icon will pop up and tell you what the tool means by that different recommendation. All right, also another little tidbit is there's another icon up here that you can click on. It has a disclaimer about the tool as well as why these are important projects. It does say that there's need for on-site visits and professional judgment to determine the final design of the project that you would like. Okay, I'm gonna really quick go through my example project. So say we're North Carolina Aquarium and we want to do a marsh plant only living shoreline project. And we type in our address up here in the address bar, it zooms in the map to that location. And now we can see these shoreline points or these grids where the suitability analysis has put these different factors and created a recommendation. Unfortunately for the aquarium, along their shoreline, they primarily are recommending a hybrid living shoreline project. If we're interested in why the tool recommends that, I'll take you to the next step here. We can click on each of these actual grids and it will show you what the analysis says about the different factors that went into it. Also, again, if you're unclear on what the details of those analysis were, you can click this methods document that's highlighted in yellow, this little button here, and a tab will pop open with the methods document for you to review. But here I want to point out the biggest factor determining that it needs a hybrid is wind wave energy, and that's got that high level score, or well, it's actually ranked low. But if we're interested in looking into why it's recommending that on the tool, we can go below those different 3 buttons, and you can see that there's this living shoreline suitability factors. And you hit that and the little plus sign, and it expands and the map changes. And we have all the suitability factors that went into the analysis that we can see now. It will open with wind wave energy, which we can see here is the dark purple, saying that along the shoreline we have high wind wave energy exposure. And if you're a local, you know this is a lot of open water and there's nothing blocking the wind, so we're just getting beat up here. And that's the biggest factor for this location. Just a few more things that I want to point out. We also have the ability to look at the boat wake. You did see in the previous aerial, there was a boat there, but the distance, and you can measure that with the tool and that factor that's in there, but we can see that that's not necessarily a huge risk. It's shallow along this area. And then below the boat wake energy, we can see there's additional layers that we can look at. Existing projects is one of them. There is a project in this location. It is actually a hybrid design. The plants are successfully thriving. and they can discuss with the public, and you guys can even visit this site if you wanted to determine kind of what the tools-based analysis is telling you and if it's jiving with your on-the-ground knowledge. Just a few things I want to point out real quick. The methods document, there's also a county summary. If you're Carteret Onslow County or you have someone there, you can print out that county summary. It's about living shorelines. There might be information to share with the homeowner. There's also the PDF map, as I said, that you could share with a homeowner, a save and share link. And we have a workflow, I believe, is that in the training manual, I hope, that you can consult after the fact if I run through this really quickly. But there's also a website that you can find more information about the tool and the analysis. But I really encourage you, if you have any issues or you want individualized training or assistance, please reach out to me or any of the scientists. If you have some expertise and knowledge that you want to improve upon the tool, we're always willing to do that. And then we'll stop there.
Wonderful. Thank you, Laura. Happy to take questions for Laura. If there are any, you're welcome to come off mute or put them in the chat box. I'm not hearing any questions, but you are welcome to put those in the chat box if they come to you. And of course, reach out to Laura if you have any questions. And I did want to point out that the speakers' biographies and contact information is on the second page of the training manual. So you do have everybody's email and phone number. All right, thank you, Laura. Appreciate your time here today. Now I'm going to turn it over to Tracy Scrable, who's going to talk about visiting your site and doing an on-the-ground assessment of conditions.
Okay, good morning, everybody, and thank you all again for attending on this beautiful day. Maybe you can get out to a shoreline this afternoon. So I'm going to talk a little bit about the second part of the assessment, and I love that tool that Nature Conservancy has presented. It is, as Laura said, a screening tool. It's also an educational tool. It really gives you, I think, a behind-the-scenes look at how these wave and wind factors, boat wakes, et cetera, translate into energy along shorelines and our abilities to stabilize them, recognizing that there is always a need for this site assessment. So I'm going to talk a little bit about that. So I prefer to do the desktop analysis first for any shoreline that I work on. And that really sets me up for the things I want to pay attention to when I go out to any site. And so that's why we had Spencer's section first. I'm going to talk a little bit about what you look for when you go out to the site and tools you can use. And again, these things are meant to work in concert. So one of the things that I've developed over the years, and there are tools that we provide you all as practitioners, are our site assessment worksheets. We have two different worksheets that I wanted to show you that I like. I'm showing you two because I don't think either one has everything that I like when I go to a site. So we're going to give you two tools. I think only one of these, if I'm not mistaken, is in the manual at this point. I believe it's this one. There's another one that we have that I'm going to show you from New Jersey, but we will be adding that to the manual. So when I go out to a site, I like to have a worksheet. And the reason for that is that if I don't, inevitably I get back and I've forgotten to look at something. And that something becomes critical either during permitting or design. And it's just really easier for me to actually have something that I check off when I'm in the field and give me something to write on. Of course, I also take photographs of every shoreline when I'm there. But I really find this sort of streamlines your assessment. And I'm just going to briefly go through these factors, and then I'm going to spend a little more time with a couple of these in later slides. So this one again is a tool from Virginia Institute of Marine Science, and they actually have a whole training for you. They have online trainings, and they used to have in-person trainings, and this is one of the tools that I like in that training. So basically, some of the things you heard Spencer say, some of the things you heard Laura say, and then things you will witness out there. It's really kind of an investigative look when you're in the field. You want to kind of understand what's going on, and in many cases, you only get a snapshot. So if you only have one visit, in other cases, I know I need to come back to look at things maybe during a heavy storm or just to get different tide conditions. But shoreline orientation, sight length, those things are very, you've heard before, the average fetch. And again, you should have the fetch information from your desktop analysis, but it's nice to kind of translate that to what you see in the field. Shoreline morphology is what type of, what are we looking at here? Are we in a kind of protected pocket, or are we a headland that's stuck out in the waterway? I want to pay attention to what I see in that near shore area. I always check the depths right off of the shoreline where I might need to put structures. And I'm looking for not just, is it shallow all the way out, but what is the condition of that substrate? Is it muddy? Is it sandy? Are there a lot of sandbars that are going to break down the wave energy? And then right under that, I'm looking to see, are there existing resources that I'm going to have to pay attention to or utilize, such as oyster reefs, submerged aquatic vegetation you'll hear about more. Tide range, again, you should know that from your desktop analysis. What is your erosion rate? Again, this is subjective, and you cannot really tell what an erosion rate is during one visit, but you can get some clues looking where the rack line is. If you're there right after a storm, you can look to see where the storm elevations or surge has taken you. The boundaries, the site characteristics, I always look in two directions when I'm looking at a shoreline: what's happening from the waterward side, and then what's happening on the upland land use. And I'm going to talk a little bit more about that. And then the bank condition itself. So I'm looking at the height of the bank. That'll help determine a couple things: the design, but also can we get equipment in there, what the composition of the bank is. That buffer this is a Virginia tool, so that's speaking to a regulatory distance of a buffer that is in place that they need to pay attention to in Virginia and Maryland. What is the condition of my shoreline and the backshore area? Do we have boat wakes, etc.? So this is just one tool. We invite you to use it, plagiarize it, do what you need to do. Secondly, this is the one from Florida. I'm sorry, I said New Jersey. It's from Florida. And this is from put together by my friend Tom Reese, who he is a consultant down in Florida, does a lot of living shoreline projects. And there's a couple on this one that are not on the other one that I really liked. I think they spend a little more time talking about existing shoreline structures and shoreline types. And that's really important because often the shoreline you're working on is affected by what's adjacent, both on the land use side and on the shoreline side in terms of other structures. Prevailing winds when you're there and what the tide is on the day that you're there is important. Proximity to navigational channel is very important. Some of the sites we worked on just would appear to be good for living shorelines, but when you actually step out there, you're too close to a navigational channel and you could lose the structure right into that channel. We always look at what's happening with runoff, and I'm going to talk more about that. But it's not just what the runoff looks like, but what are the sources of that runoff is important. And then they look at some ecological factors, which again, I mentioned oysters and SAVs, but they're also paying attention to, do we have nesting birds in the area? Do you see any, a lot of native vegetation there that will help us to choose what we're going to plant and or preserve? And then some water quality parameters. Salinity is important. if we're talking about using oysters and determining what plants we want. So I put this in here more to say that I'm not sure that I buy this chart, but it's an interesting way to, much like, well, I would say different than what Laura presents, which is actually based on site analysis. This is really sort of a broad brush attempt to say, for these conditions on your left-hand side or these parameters, we can more or less develop recommendations for these various living shoreline structures. And again, I think it's an interesting sort of academic exercise, but I would say that I don't agree with a number of these ranges, having done this for a while. But some of them are just good for you to go through sort of a mental assessment of those conditions on the left-hand side when determining what type of approach you're going to utilize, and knowing that you could utilize several different approaches in many cases. And I'm going to show you some of those later today and next week. So let's just talk about two main things that we look at. One is what's happening right at that interface between the upland and the water. And you'll hear this over and over, but it's important that we understand the source of erosion. And again, you've heard a lot already about the fact that we in North Carolina and our estuaries, we pay a lot of attention to boat wakes, storms, etc. And then the severity of erosion. It's important for me to know, am I talking about 1 foot per year of erosion or 10 feet per year? That's a very different thing. Existing bank and shoreline conditions, again, I want to know what those soils are, very much so when you're assessing what type of living shoreline and what we can do with that shoreline. I worked on a bank up around Oriental on the Neuse that had this layer called a blue clay layer. Some of you know this, and it is impervious as can be. And when they grade their shoreline up there, water from the upland hits that blue clay layer and then slides out and erodes the bank. And it is a very difficult bank to work with in regrading. So you really need to pay attention to that. Your slope, Spencer has already talked about. And the orientation is really important. And I like to think about that when I'm out in the field, because again, it's not enough to know that generally the shoreline faces northeast, because in some cases the orientation is a little misleading. You may have an exposure to, say, a northeaster, but you could also have other factors there that are mitigating that effect, like piers and docks and other structures. So I want to pay attention to that orientation. And then bathymetry is, of course, the topography offshore. We want to know how shallow it is, how far out, that we've already talked about. And again, what are your existing structures? These photos that I include here, the bottom left one is in Topsail Beach. It's important that they were interested in a living shoreline project, but two things jump right out at you. One is there is a bulkhead landward of that narrow fringe of marsh, and we'll talk about potential living shorelines in that setting, but there's also a floating boat dock that's extremely close to where one might put a living shoreline project, and you would have a conflict there with a boat if tied off there, interacting in an unfortunate way with your living shoreline project. So, and again, existing conditions, is it a sandy beach? Is it all wetlands? Do we have submerged aquatic vegetation? And what's happening in that area between the low and high marsh and the upland? Do we have a forested area, or is it all sort of urbanized? And then I already talked a little bit about the habitats and the shoreline types. What is the water quality there? Soils are very important. Sunlight is important when you're talking about planting marsh grass. Some sites are just too shady, and we think about different types of plants there. Again, a little bit repetitious, but I'm going to do it again, is the hydrodynamics of the site are very critical when you're standing out there. And you can see for yourself the effect of boat wakes when you're standing on shorelines such as this one. This is a Topsail Beach. That's Banks Channel there. And it gets the backside of storms, coastal storms, but it also is heavily, heavily utilized by boats. And I like to stand out there and watch a boat roll by, and you can see not only what the wave height looks like under normal conditions, but you can kind of see Does it bend? Does that wave approach pretty much parallel, or does it sort of refract around structures and approach the shoreline in a different way? And then stormwater effects. I can't emphasize how important the stormwater effects are. In many cases, I'll tell a property owner, well, you don't have much boat wake erosion or wind erosion, but you're eroding heavily from what's coming off of your land. Either there's a lot of height or a lot of impervious surfaces, and that flow can be concentrated and create erosion that appears to be from the other side but isn't. So I want to pay a lot of attention to that. Tide effects are important. It's very different situation when you're in a 2-foot tide range than when you're in a very high tide range, such as 4.5 feet. I've worked on one shoreline for the state of Georgia with close to 9-foot tide range, and that is an extremely extreme situation, but it's very important because it affects not only the tide range and what the slopes and design is going to look like, but it affects that volume of water that runs alongside, so it's affecting your currents as well. So very important that you understand those things. You can get evidence of those in the field. This site here is fairly typical on the right-hand side. You've got coastal marsh there. It's actually a beautiful site that we're doing a demonstration project on for Living Shoreline. And then, but right next to it is the photo to the left, and you can see no vegetation there. It looks as though it'd be a beautiful site for vegetation. One of two things has happened here. One is during storms or enough boat wakes, you still have sand there, which could be brought into that area from erosion of the adjacent site. But you could also have boat wakes that have come and scoured out the vegetation. What I really think has happened here is the property owner has kept all the vegetation off here because they use it for their kids and grandkids. So again, part of the assessment. And I will say that my very favorite tool in doing field assessment are the human tools. And I've learned much, much more by talking with property owners, the current property owners, if they've been there a while, the adjacent property owners, the shoreline site here on the right. The property owner on the right has owned the property since the 40s. And he was extremely knowledgeable about what has happened on this shoreline and the conditions that affect it. So I would say always include as much conversation with the people who live in that area as you can when you're doing your site assessment. The other thing I look at is sort of what I would call conflicting land uses or space limitations, because many of our living shoreline sites require some materials and equipment to be brought into the site. So right away, you're asking yourself questions of, can we regrade the upland, or do we need to regrade the upland? You're going to, in many cases, if you have a scarped bank, you're going to need to do one of two things, either to regrade. You're either going to grade it backwards towards the land if space is available, or you're going to grade it into the waterward side. And in many cases, that just isn't a possibility because of other resources there, or you've got existing marsh, or it's too deep, or whatnot. But anyway, you're looking at the regrading issue right away for many of our sites that we're walking out to that have cut banks. Are we going to be protecting existing marsh grass if it's already there and we're just losing it at a rate that's not acceptable, or are we going to be restoring lost marsh? We do both of these fairly regularly with all of our living shoreline projects. So that's a question you need to ask. And again, I'm going to talk about the site on the right in just a minute. And again, when we talk about extending the shoreline into the waterway, that is in many cases a regulatory question as well as a design question. So that's why you have to develop a relationship with your regulatory folks. What are the adjacent land uses? How close are the structures? This is a good example. This is a condominium development here. They called us out there because they had a hurricane that brought surge up into their first floor. The reason is not 100% obvious in this photo, but that is an extremely steep bank from that patio to the existing marsh here. And this project, you're looking at it post construction of a living shoreline. But you can see that house is about 15 feet from the high tide marsh. Very steep bank, lots of runoff coming off of this. And the fix, if you will, here, and they had a cut bank that was causing them a lot of concern. They still had marsh. The fix was a biolog project, which I'm going to show you. We basically created almost a vertical interface to stabilize that cut bank while we replanted some of the lost marsh. We regraded the bank and put in more vegetation to absorb the stormwater runoff. And then in this case too, it was really important to look at adjacent property owners, which were bulkheaded, and there was no marsh in front of them. So it gave us confirmation that what the energy levels were here, but also that a living shoreline project would be optimal here. Just a couple of additional resources for you. Again, the training that we're giving you is technical, but there are trainings that you can avail yourself to that have many more detailed resources. One of them is the Virginia Institute of Marine Science. They have an online training tool here, website, and then they often have in-person trainings, although I think that's been a while because of COVID and other reasons. The Living Shoreline Academy is a website that we helped put together with some other national partners. And there's 2 trainings on that, one for property owners and one for contractors and other technical folks, and then other resources for you. And then I really like this Living Shorelines Engineering Guidelines put together by the Stevens Institute at Davidson and for New Jersey. And it's a really nice, very technical training with some nice tools for you. But at this point, I think that is the end of this portion, and I'll turn it back over to Whitney for questions or a much needed break for you all.
Yes, why don't we just pause for a moment? You're welcome to come off mute if you have a question or put it in the chat box.
Tracy, could you possibly email us the New Jersey assessment that you said is not in the manual?
Sure, happy to. I lied about that. It was Florida.
Okay.
There is a assessment tool, I believe, in this New Jersey document that you see at the bottom of this list. But the one that we're going to put in the manual that I like was put together by my friend down in Florida, and we can email that out.
Great, thank you.
You're welcome.
Break. Tracy will be picking it back up again with some site design guidance.
Hey, welcome back, everybody. So we want to give you this week really sort of a preliminary introduction to this different types of site designs for living shorelines that you might utilize, recognizing that we're really focused on residential settings here. We've done living shoreline projects, and some of you all have as well at larger sites, but we're really going to be focused on the residential typical shoreline setting. Next week, and this is the hook to come back, we will give you a great deal more details on the site design. That is, we'll provide you with some plans, site designs. We'll talk about materials, cost, availability, resources, and then more case studies, some of which you see I'll introduce today, but you'll get more details next week. So please stay with us. When you're talking about living shorelines, one of the things I want to emphasize is that that's really a suite of options. There's no single, as you well know, living shoreline approach or situation. And they range from what we call the green or the softer techniques to those hybrid or harder techniques. And in shoreline stabilization in general, you can see from this nice little cartoon here, the range of options from vegetation alone to truly hardened approaches of things like bulkheads and revetments. So this resource I like, we want to give you resources too along the way. This is a SAGE, or the systems approach to geomorphic engineering. It's a website that has a lot of tools, and they give you some really nice descriptions of these different living shoreline techniques and where they might be appropriate. So again, just another resource for you. So you'll notice some of the people on this talk are going to go into sleep mode because they've heard me give this talk before. So don't pay attention. But anyway, when I talk about the hierarchy of erosion control options and living shorelines being in that suite, I like to start with no action approach, because there are certainly places where you might go, and although there's a tiny bit of erosion, the property owners may see it as a real threat. But there are times when I will say to them, you don't have a problem and let's not create one. And there may be some things like planting marsh grass, which you can do at any time, most often without a permit, but we don't want to overreact and create a situation. So relocating threatened structures is another possibility in some cases, maybe not the one we're looking at in this site here at the north end of Figure 8 Island. Non-structural measures, those would be vegetation alone, combinations, and then again, hardened structures. And I will say I visited that shoreline site that you see, or the picture you see there, was during construction, near the end of their construction. So they actually built that house in that location, and then wanted to do a living shoreline, which was most unfortunate. So one of the options in that suite that I mentioned, which is, I would say, a very limited application, but I want to just throw it out there, is the addition of clean beach sand as a living shoreline approach. And again, very limited, particularly in residential settings. But in this particular case, which was at the Cape Lookout National Seashore, where they have a policy of no structures, and the historic shoreline here was already a sandy beach, and there was no conflicts with either marshes or submerged aquatic vegetation. It is an approach that is in our suite, and basically it's not doing anything to change the erosion rates or the sources of erosion, but it did sort of buy them time by setting that shoreline offshore, as you would on the ocean coast with beach nourishment as well. Moving up just slightly into the vegetation bank, regrading and planting. I love these little cartoons. They kind of show you, and I'll run through different scenarios here, but you can see where that we're talking about, in many cases, a little cut bank here. And in most cases, we might have some marsh left, or we might have lost that marsh, and the profile is too steep at this point or too deep to replant, and so we might need to do a little bit of bank regrading, if possible, and then replanting marshes. And this is a great technique for low energy settings. When you're talking about vegetation only, you really have to understand what the sources of erosion are and the levels and energy levels to know if marsh planting alone is going to be sufficient. I would say marsh planting alone is a relatively inexpensive alternative, and I have worked with property owners who did some marsh planting and then realized they needed a little bit more, and that's fine, because they tried the cheapest alternative first. In as many shorelines as I can, I like to include both that marsh planting, vegetation, either restoring marshes or preserving existing marshes where you can, but I also really want to include that shrub zone and the riparian zone. So those can be the shrubs and the trees, or forest, if you will, and that can be both areas that are within super high tides or upland of that. And there's a lot of reasons to do this. Some of these are ecological reasons, because it's that zone between that riparian buffer and the submerged areas are where a lot of our critters use this, who are estuarine animals. And that connection between the upland riparian zone and the marsh is really, really important. Those areas also provide a lot of shade for the nearshore area. And in the Chesapeake Bay, when they really started seeing problems with water quality, they traced it to a loss of upland buffers, and shading was one of those issues. And then also those particular plants, and in many cases that texture, if you will, is where we're getting a lot of the assistance in mitigating stormwater runoff. So you cut down trees, you cut down shrubs, you oftentimes are increasing the stormwater runoff that's really causing a lot of shoreline problems. Please do unmute yourself, ask questions along the way, or jump in. You can give some examples if you like, or not going to bother me. Okay, so moving up a little bit to slightly a little bit of protection in terms of a structure are these methods called biologs or core logs, or they're basically coconut fiber logs that are, and I'll show you some pictures of them. I saw this a lot when I worked in the Chesapeake Bay. They really did a lot of the work there, and they actually, the Chesapeake Bay Foundation holds a lot of trainings for property owners, sort of do-it-yourselfers, to actually construct these type of approaches. Relatively inexpensive. I would say their application is on the low end of energy. They are not designed to be permanent, so they biodegrade. And you'll see a better picture of this in a minute. But the idea is that they're holding that toe so that the marsh that you're restoring or enhancing can really take hold and start to hold its own. And in some cases, I would say moving into the more moderate energy regime, I've seen some nice projects where they actually apply a little bit of stone at the toe of that. Again, it's just it's holding that biolog outer edge in place where you might have a little more scour potential, but still not increasing the cost and the amount of stone that's needed. You can do the same thing with oyster bags, and I've seen that as well. We'll talk about that. So this is another project out of the Chesapeake Bay Foundation. You see a lot of these core log projects. And again, we're talking about at the low energy regime here. You can combine them with other measures, as I mentioned. And again, they talk about 18 months of that biolog will be in place before it biodegrades. It's got kind of a jute matte outer coating on it that just breaks down. I'll show you some pictures of some that actually have been in place almost 10 years, and there's still a little bit of the structure. I think that I've read and heard that many of these are better in freshwater systems, that they just don't break down as well. Some of you may have an experience here on this, but I've used them in saltwater environments. I know a number of other folks have. And this is just a design. Again, you're going to get more of this next week, but my friend Tom Reese with ESA Consultants down in Florida, just to show you what it might look like from a site plan view. They are held in place with these wooden stakes that, again, property owners can drive in, and then they have basically heavy-duty rope or string that ties those stakes across the top of the core logs to keep them in place as the tide rises and falls. So this is a structure site that I worked on in Chesapeake Bay. A lot of you have seen me share this. This actually happens to be my brother's site. He went to one of those DIY clinics and then promptly made his family help him do it. So this is actually on a creek right off of the main stem of the Chesapeake Bay. And I would call this moderate energy. And when we first came to this site, this is where the shoreline was, right here. And it was a pretty steep cut bank. There's a lot of elevation on this shoreline. So we regraded this bank. This is a first line of planting that we did while we were also establishing these core logs. I show this for a couple of reasons. You can terrace these structures to really, if you've got a lot of elevation and space in your bank, you might need 2 rows of these structures. So we put one in low that would protect the shoreline from the energy while we establish the low marsh, and then we put in a higher one, again, just to create a terracing effect. Right as we were putting the structure in, 2 weeks later, a big storm came in and rolled. We're very close to the mouth of this creek. There are 3 large bulkheads right in the adjacent property here, and the energy from those came in and tore out this section right here. I want to sort of recognize the fact that these are structures, while they're relatively easy to do and inexpensive, they also are subject to breaking down in really high energy conditions, as happened in that storm. We went back and put them back in. This is right after the second that section was taken out, and again, it's relatively inexpensive, and we were not deterred. And this is what it looks like now, almost 15 years later. And you can go in here, they don't own this property anymore, but you can go in here and you can see the second line of core logs is still in place. The lower edge is not so much in place, but they did go in later and put in oyster bags because for whatever reason, the conditions changed slightly in this creek so that natural oyster recruitment really increased. And so my brother, who's a novice oysterman, went in and put in some oyster bags at the toe here. But this site is extremely stable, as you can see, and really very effective. So I'm moving up again into the energy levels and the hybrid projects. That is, we're integrating more structures with the marsh planting enhancement or protection. And I want to say this over and over, no living shoreline project can be a living shoreline project if you don't have vegetation associated with it. It really is not something, the vegetation itself provides us with so many of those benefits from an erosion control standpoint, from a water quality standpoint, from an ecosystem standpoint. So we wouldn't go in and put a bunch of structure out there if it wasn't tied to some sort of a marsh restoration or preservation project. But we get into these higher energy and we have lots of options. I'm going to show you just a few. So again, under the category of, I doubt you'll see many of these in North Carolina, but I'm going to just show you. These are actually, you would know these, I think, as sort of very short groins. This is used a fair amount. I'll show you a project here in a minute in the Chesapeake Bay in the upper reaches of many of those creeks where they've lost a great deal of their marshes to boat wake erosion. And a lot of these creeks are very narrow with now a lot of cut banks and over steepened banks. And so this approach is where you have a longshore energy as your dominant force of erosion. So you get these currents set up, or the boat wakes really set up kind of angular waves that are approaching at an angle. And so what we're doing here is we're just stabilizing a newly regraded bank and marsh planting until it can take hold on its own. And just to show you a project here done by my friends up in Chesapeake Bay, this is in Maryland. That bank here, this was a very steep bank, probably about 10 feet high, and EPA funded a number of these projects, and they allowed this bank to be regraded to reestablish this planting grade. This is what used to be here, so this is what was eroded away, and you can see the structures here and here. And then the marsh plants were held in place. And once this marsh takes off, as you can see here, this is not even 2 years later, the structures become really sort of the less important part of the erosion control here. But these sites, I've gone back and visited these sites decades later, and they are still doing a great job. You won't see many of these in North Carolina. They do have some application. We actually have one in Emerald Isle for demonstration purposes, but mostly our energy is more on and offshore than alongshore. So you just, and we also have more resources where pushing fill out into this area is going to be a problem. But I throw it out here for you. Vertical wall sills. So the term sill really refers to a number of different structures, but what is constant across them is that these structures are placed channelward of where we want to protect or restore our coastal marshes. And they can be made of a number of structures. Some of you on this call maybe have worked with these. This is a vertical wall sill cartoon. And really what you're talking about, I'll show you a photo in a minute, but this is kind of a bulkhead design, but extremely low profile without any tiebacks or fill. And again, placed channelward of that marsh. They're useful in areas where you don't have the either access or the slope is not right or the bottom is not correct for a larger or a heavier structure like a stone sill or even an oyster bag sill. And so these vertical walls have been very effective in just providing enough dissipation or breaking down of that energy to allow that marsh plant, those marsh plants to flourish. Here's a number of them just to show you some examples. I believe this one is at Pelican Point up around Topsail. You see they are gapped and very low profile here. This one has a cap on it for kind of aesthetic reasons, but where that gap is right here, we're concerned, this is on the intercoastal waterway, so you get a lot of boat waves. So they put in another section back here just to break down that energy, but still allow fish and other critters to move freely around these structures. This happens to be one here down in my neck of the woods, and this is maybe 100-foot wide channel across here, maybe 150 at the most. Very space limited, but they were losing this marsh pretty rapidly to boat waves. And so this is a very low profile. It has worked beautifully. The one in the bottom right is at Morris Landing. You'll see that structure during the field day. And then the bottom left, I want to remember that this is Ocracoke after one of the hurricanes. And I put this in here to say, because these structures are still in the vertical world, they are subject to extreme wave energy, providing a lot of force against them if they are either too high or maybe they are not designed quite heavily enough for the incident conditions, or there's no tiebacks in these and there are no backfills like a regular bulkhead. So that is one limitation you need to pay attention to. This structure probably did a really great job until it didn't, and you can see it's starting to have problems here and this was one hurricane that really came in and affected a number of structures, lots of bulkheads, and this particular sill. This is a site on Albemarle Sound on Kitty Hawk area, built and designed by the property owner himself, he's a builder. And this is at the high energy end. So I like this structure because it met what he wanted to do, which was reestablish these little mini headlands and get that black needle rush and riparian buffer to reestablish. And it is a pretty open fetch situation here. So this is a large vertical wall sill, but you see the gaps in it. It also has, you can't really see it in this photo, but they are, he's used kind of a U structure, and then the next one over kind of overlaps with it. So they sort of are interlocking sills. And again, it just points out, you really, if you understand your energy conditions and your shorelines, you can design these even for high energy settings. And if you're out there, that's probably a 12-inch piling supporting this structure. And it's done a great job. And all of that needle rush that you see in this has volunteered in since he did the project. Some of these sites we can give you all access to. This one I was taken on a tour. This is a private shoreline, so you can see it by boat, but you can't get there. But we're happy to set you guys up to look at some of sites that we have in your region if you let us know where you are. So again, sills with plantings. I'm moving now into more of the structural sills. This design, the trapezoidal shape that you see here, this one is really designed to work even from moderate to high energy settings. And what is consistent across them is this is again channelward of the marsh grass. In most cases where we're working now, we'd never add fill anymore. The structures themselves do a really nice job of retaining sediment that comes in during higher conditions, some storms, and build up landward of these structures. That's really important in our current situation of watching sea level rise, local sea level rise, really start to ramp up in almost all of our regions. And in natural settings, many cases, our coastal marshes are struggling to keep up with that level. And so having these structures to retain the sediment and allow that accretion to happen is, at least for the moment, allowing us to keep pace with local sea level rise. So a nice effect in addition to erosion control. I'll just show you a couple of different situations where we use these larger structures. These are mostly open fetch or higher energy sites. On the left is in Columbia on the Albemarle. This is an open fetch shoreline, high energy. And what's also unique here is it's a freshwater, relatively, it's brackish, but really fairly fresh in terms of the vegetation that wants to grow there. And so we developed a list of, and you'll see it in next week's projects. We'll show you the plant list for these areas. But you can see this is a large stone structure here. It is open to flushing both through the structure and at each end. And it was also protecting some bald cypress that they particularly were concerned about. You know, bald cypress can live in the water, but these were being really sort of beaten, and they had lost a couple during storms. On the right is a more saline situation. This is on Pivers Island in front of Duke University's property. I like this project because in one photo you see a full-size revetment up against a bulkhead. You see a stone sill that we put in here with marsh plantings and a riparian buffer berm here that protected the shoreline from runoff coming off this road and eroding the bank. And then you see a full-size bulkhead here. And you can kind of see what we're after here is this connection of tidal marsh, riparian upland, versus this structure is definitely protecting the shoreline, but we're not getting those other benefits that we're looking for. We do have oysters growing along the entire toe of this revetment as well as the sill, not so much on the bulkhead here. And this is again the project in on the Albemarle that I showed you before. And I just want to show you again from a design standpoint the difference between a revetment and a sill. That revetment is probably 10 feet high. That's a lot of stone. It is protecting the upland, no question about it. But in terms of our ability to continue to protect and get all the water quality benefits and the ecosystem benefits of shoreline protection, it is not doing much of a job at all. And we're also getting a lot of, they were using a lot of fertilizer, so property owners just needed some education, and they have done a nice job of backing off on their fertilizer as well. And you can see we were able to really get a nice, albeit fairly narrow fringe of freshwater wetlands here. Their houses are pretty close, but a nice little project, and it's very stable today. Another site, just to show you, also fairly high energy. This is on the Chowan River, and you see this when you drive over on the Chowan River Bridge. This is the Wildlife Resources boat ramp that's heavily used there on the Chowan River in Edenton. And we were approached by them because they had a failing bulkhead. And the Wildlife Resource Commission has done a nice job of trying to integrate a number of different, I would say, environmentally beneficial design options into all their projects, not just living shorelines. So in this case, what we needed to do was pull out that failing bulkhead, regrade the shoreline. We established a freshwater suite of plantings going up into the tree line because there was space to do so, and then a stone structure with gaps. And again, this is a large parking lot here, and they also integrated a number of different design options to keep all of that runoff from that parking lot from going what I call overboard. But the Living Shoreline project itself did a really nice job in buffering the runoff from that parking lot, which was contributing somewhat to the erosion on the site. And I just had the opportunity this year to visit this site, and you can, as you're coming off of the bridge going into Edenton, it is the last or the first exit, if you will, that takes you to this wildlife ramp, and you can go and take a look at this. This is what it looked like just in November of 2020, and extremely stable, really doing a nice job from an ecosystem, from a water quality standpoint, from a fishing standpoint. A number of fishermen were out along here a couple of times when I visited this site. And the upland portion of this is beautiful. There are a number of trees and shrubs that have volunteered in that we didn't plant. And so I'd say the site is really evolved into a fairly mature, stable shoreline. Oysters. We have incorporated oysters into many of our sites and living shoreline projects, as have some of you all on this call, where they are appropriate. And the biggest key to where they are appropriate is when you're visiting that shoreline, do you see native oysters growing there? Are they established? Do you see the effect of enough larvae in the water where you see spat on whatever it is, docks, piers, stone, other structures, to know that we can incorporate these options as structure into our shoreline. And I'm going to show you just a couple of different kinds, starting with the loose oyster shell. Again, from a residential setting, I doubt very often that very often this would be appropriate, because property owners want a little more comfort, and we're able to use loose oyster shell in very low energy sites and feel very good about it. But oftentimes there's just a little too much energy when we go to these properties. So I'm going to show you a couple of different approaches, including oyster patch reefs. So this is a loose shell option over here, and then this is bagged oyster shell. So I'll show you some different options. So the loose oyster shell, this is our property, Morse Landing, that we're going to visit on our field visit. And we engaged a local contractor here who basically power washed off oysters into what looks, you would think, fairly haphazard, but it actually isn't. It has a nice design height on it that we wanted, knowing that he put this structure in place in the location that was close to the shoreline, but we knew that Mother Nature was going to come along and redistribute that shell and basically take some of the elevation out, spread it out so that it would form that substrate for significant oyster attachment. This is Stump Sound, so some of our highest quality oyster waters in the state. We knew we would get a nice larval set, and we did. On the right here, we did not know that Hurricane Matthew was going to come and visit us, which it did. And it did move some of that loose oyster shell into the marsh, but we still were left with significant substrate here. Again, we own this property. As you can see, there are no structures that we're trying to protect. So we use this as an experimental shoreline to tell us a number of things, like what's the upper regime for using loose oyster shell. The bottom left is off of Jones Island, and this is a patch reef that it's a restoration project that Lexia Weaver, my colleague in the central part of the state, worked on. And I believe this is Jones Island. It could be another place on Bogue Sound, but again, for residential settings, you would very likely not do this, but I wanted to show that these reefs, which we restored for the reefs themselves and that ecosystem function, also provide erosion control for the area landward of that. And we were able to plant marsh and get a very stable marsh growing landward of this structure. And then oyster domes. So oyster domes are a prefabricated structure. We get ours, or we have gotten ours out of Virginia, and they incorporate oyster shell into them, but they are available commercially through a number of companies now. And we really like these in areas where you have enough stability in the substrate and the elevations are right, to use them as a sill type structure, either as a single line, a double line, a terraced effect. Again, what's key about using these is that you are placing them where you're going to get oyster settlement on all parts of that dome. You used to know these, this is creepy as can be, but you used to know these as the memorial reefs. I mean, they were designed for fishing purposes as offshore reefs, but also now people can be incorporated into them when you pass away. Not saying I did thing, but that's how one of the ways I first saw them. So we haven't done that, so don't worry about it. But anyway, they're available commercially. And I'll show you two examples here. The bottom left, these are large structures, much larger than you could wrestle with using volunteers. This is in front of Carteret Community College. Carteret Community College? Yes, Carteret Community College and NC State University has property on Bogue Sound, and we incorporated this into a number of demonstration projects. And although you don't see oysters growing all the way up this structure, the inside of these are full of oysters and fish and crabs and all sorts of critters, and they've done a beautiful job of stabilizing that shoreline for the marsh that is eroding behind them. On the bottom right is Morse Landing. You'll see this one, and we were fortunate enough, we really hit it correctly with our elevations. And we have oysters growing on all sides, which increases the stability of them and also their functionality for erosion control as they dissipate wave energy and as an oyster reef itself. We have a little section here landward of a different approach that you'll see when we get out there. We were just trying different things again at this shoreline. Marsh tow revetments are another structure that is permitted under the general permit. This is a structure, again, it is a form of a sill. This cartoon doesn't really show that, but I'll show you a picture where you have an existing cut bank and you have coastal marsh, and you're not looking to restore coastal marsh, but you want to hold the line, if you will. We've had a general permit in place for a while now to put a little bit of stone, usually with filter cloth, but sometimes not, or you can use oyster bags to do this at the base of that eroding marsh. And again, what makes these unique from a full-size sill is that they're generally smaller in structure. You do not have them established channelward, 5 or 10 feet from the marsh. They're right up against that bank, and they have relatively low elevations, no more than a half a foot above high tide. Just show you a couple of examples. Again, when you go out to the side, you would say that's a sill, and for all intents and purposes, design-wise, they do end up usually looking like a sill, but they utilize less resource, if you will, space-wise, in terms of, I think the limit on these is 5 feet on the base. But oftentimes, this is all you need to break down wave energy from a boat wake erosion type setting. And you can see we get a really nice oyster settlement here on some of these structures. These are oyster bags, which you'll see in a minute. And again, just another site to show you, they can actually have a little bit of size on them. They can be 2 or 3 bags high, or as long as depending on what your profile looks like, as long as they're not more than half a foot above mean high water on the crest elevation. And again, we get a lot of bang for our buck in terms of oyster settlement, which further stabilizes the shoreline. We would not put this structure in here if you didn't have a fairly high confidence that you're going to attract oyster settlement here. So oyster bags, I just showed you a couple of different options of those. So we often do these as volunteer projects, at least we did prior to COVID, and we will again. But basically these are, you'll see a lot about how you build these, how you construct these. Next week, we take you through the whole process of building these, but we really like them because they're portable and we can build these shoreline projects with volunteers, community. It's a great community building, and you can do a whole, I'd say, 50, 100 feet in a day, no problem, depending on how many folks you have, actually even more. And they're relatively light. This is one of Lexia's projects, again, in the White Oak River, and I would say I would categorize this as higher energy, really vulnerable. This is Jones Island. You see from the double bridges as you go across on the White Oak River. And I think they did about 1,300 feet here. This was a volunteer project, and we love this project because we kept kind of the eroded features there, those trees which provide habitat for animals using this area, but we really established a very nice oyster bag reef that was then totally encrusted with oysters in a very short amount of time, and is very stable today on the shoreline. You can see this. You can see the Jones Island when you drive over those bridges. I wanted to show you what they look like, just a more close-up version here. When you first put them in, these are bagged shells. So we are using a open mesh plastic bagging. There is research going on that we're very much in favor of ways that we can reduce the amount of plastic that we use. And I'll touch on those in a little bit, but if you are successful, and where they should be used is where you get a lot of coverage of oysters so that the whole structure becomes encrusted in oysters, and these bags aren't breaking it down and getting into the environment. I'm not going to say that the plastic itself is not degrading and contributing to the microplastic issue, because it is. But we're all working on other alternatives, but for now it is a better alternative in many cases than some of our hardened structures. Innovative sills, innovative structures. Again, you're going to see more of this next week. I'm going to highlight a couple of the companies that work in North Carolina, and I don't mean to exclude others. It's just we have examples and partnerships, and we know these structures have done well on our sites. So, but these type approaches are expanding rapidly nationwide, and we're very happy about that. As practitioners, the goal is that you should be able to just purchase these structures or purchase the materials for these and then put them on the ground yourself. Both of these companies allow that. In fact, that is what they're moving towards. The Oyster Catcher, the Sandbar Oyster Company. Some of you may know Niels Lindquist and Clammerhead, who own this company, and they've developed this various different building techniques with basically sort of a concrete coating over flexible materials. They create tubes, they create what's called tables, all kinds of things. And the reason why they seem to be so successful is that they're built up in the water column, and they allow oyster settlement on all sides of these structures. And they're extremely versatile in how the designs can be altered to create different living shoreline structures. The one on the left is Pine Knoll Shores Aquarium, and it has been extremely successful. The bottom one is Oyster Castles. Again, each of those little structural elements are sold individually, and they sort of fit together like Legos in all kinds of different design options. And where they are placed correctly, you see the kind of oyster growth that you can expect to see on these structures themselves. I like these structures a lot. Again, there are site conditions that really would tell you that these are good alternatives. These can be kind of heavy on the bottom right here, so you don't put these where you might have a muddy soil, or you don't have the kind of soil stability and sandy bottom that you need to hold them up. I'm going to just say for one brief moment, lots of people approach us about putting living shoreline projects in front of existing bulkheads because they don't want to see their marsh lost. And what we know about the ability of marshes and the value in marshes in even very narrow fringes are reasons where we would advocate for this. Having said that, I'm practical, and in many cases, putting a full-size structure in front of 5 feet of marsh and in front of a full-size bulkhead is a very expensive proposition for property owners. And in the era of storm energy, high storm energy, hurricanes, northeasters, whatever it is, in many cases, the risk of this is that you still can get energy by design that comes up over these structures during big storms, reflects off of that bulkhead and scours out that marsh from those storms. And so the sill, there's just not enough space between where the sill is and the amount of marsh that's still there to keep that energy off of that bulkhead. And so I'd say there is application for this, and there are folks doing some great projects in this way, and we have some of these as well, but it's not for everywhere. And I think these have to be used with the understanding that in an era of sea level rise, it's not allowing that shoreline to migrate landward and upward, which is what we really want for long-term resilience. But I want to throw them out there as a design option that has some value. I believe that is the end of this session. And I want to just point out again that we're going to get into a great deal more detail about these design elements with more information for you all on how you build these things and the cost and where you get the materials. At this point, I'll take some questions or comments or share your own experiences.
I have a question about the chemicals used on residential sites.
Mhm.
Would it be because, you know, a lot of homeowners, you're not going to convince them not to use pesticides and fertilizers on their yards, you know? Would it be possible to install a small buffer that would absorb that between the yard and the start of the living shoreline, or even maybe just like a small, like a flower bed border? Would
Yeah.
that help or?
Yeah, absolutely. That is a great point and a great suggestion. And we often do that. We really try hard. In that setting that you just saw where you got a bulkhead down in the marsh, I would definitely have a conversation with them. And we've been successful because some people just don't understand what the effect of what they're doing is on their shoreline. So you could absolutely incorporate, and we have in many cases, there are a lot of shorelines where you've got a lot of stormwater and also a lot of fertilization, where we will recommend a 10 to 20 foot buffer of something like Spartina patens or the salt meadow hay, and something like a sunflower or, something that is growing native in that area. And in a very narrow fringe, you're getting exactly what you're talking about. You're getting a lot of absorption. That's why I really like to incorporate that scrub zone and a riparian buffer for exactly the reasons you're talking about. But we've been successful in getting folks to do that. You can also integrate what I call a real shallow berm between your living shoreline project and the landward uses. In many cases, they will go along with this if stormwater erosion is creating additional problems for them, as you create sort of a shallow swale and then a shallow berm landward of your structures and your marsh, and that infiltrates a lot of that stormwater runoff, and then the berm itself is sort of a barrier to concentrated flow. And the property owners like it because it's taking care of a stormwater runoff problem. We like it because it's infiltrating polluted stormwater runoff. And so and then that is planted in whatever your natives are. It could be planted in turf, but it's more of a physical barrier to put that runoff into the ground. So that's a great question. And we try every chance we get to get people to do that.
Thank you.
Happy to send you photos of some of those if you want. Got some good examples of those.
I had a question about the sills. If you're doing a sill, is it mostly granite, or can you use if for that energy either the castles or marl or something else?
Sure. You can use lots of different options just depending on the energy levels. I've used marls as full size silt. The density, the specific gravity, the shape of marl and how it kind of crumbles provides a little less protection from highest energy sites as compared to granite sills. And in some cases, I think, can't remember whether it was Laura or Spencer that showed the site on Ocracoke, very high energy setting with stone. That is the appropriate use of stone at these high energy sites. We really have moved towards layers of oyster bags, those vertical wall sills, and oyster domes. You can layer oyster domes, 2 or 3, and good size oyster domes, which again have concrete in them, but we're moving away from stone where it is applicable.
Tracy, if I can add to that,
Sure.
one difference in the material between granite and marine limestone is the density of the rock. Granite is about 150 pounds per cubic foot of material. And that's considerably denser and heavier than marine limestone, which is only about 120 pounds per cubic foot. And that's actually about the same weight and as density as sand. Now, that doesn't sound like a whole lot of difference, but when you start stacking these up and look at the overall stability, it's actually quite a bit difference. If you look at the equivalent stability of granite and marine limestone, it takes about a 70% heavier stone to have an equivalent stability. And that would be about the same for concrete riprap as well for the same size material. So the density of the material does make a big difference. The heavier the material, the better. Granite and concrete are typically the heaviest we've got access to locally.
Spencer,
And
do
then
you know
also,
those
sorry.
oyster castles too off the top of your head?
The oyster castles and patented units have interlocking capacity, so they're different. A number of those are made out of the same porous concrete material that you use in concrete and block. So the density is probably closer to limestone than it is to solid concrete.
And again, I think their application is much, I think you can feel more confident about that where you're using them as an oyster reef. So you're getting the benefit of the structure itself and also the extra stability of the oysters encrusting on the structures. And the other thing about the difference between granite that Spencer just touched on is the shape of the granite. You know, they're very angular compared to limestone, which is often more rounded. So when you're trying to build a trapezoidal shaped structure that is stable, particularly in high energy, that limestone can roll a little bit in some cases, and the granite really locks together. So
Any other questions for Tracy? All right, well, anything comes to mind, be sure to put them in the chat box. We'll have time at the end to address any additional questions then. Thank you, Tracy, for that overview of site designs. Now we're going to turn it over to Tara McPherson, who is the district manager at the Wilmington Regional Office for the Division of Coastal Management, and she's going to walk us through permitting living shorelines. Thank you, Tara.
Hey, Whitney. Hi, everyone. Good to virtually see some of you. I'm going to talk about the permitting side. I can say I have personally lifted oyster bags with Tracy, volunteering to build living shoreline that we permitted for Coastal Federation. If you have not done that, you should. It's a cool experience, and then you can go back and see how things change over time with the structure that you help build. And it's very educational. Our office covers from the South Carolina Brunswick line up through Surf City. We have different field reps assigned to different areas. So depending where your project is, you might be working with someone down south, and Topsail Island is now divided where Morehead City is covering North Topsail North. So we had a little bit of a territory change, but that should actually be released out soon, and there should be new maps for the public. Living shorelines require permits because they meet the 3 criteria that determine if you need a permit under the Coastal Area Management Act. The first of those is the proposal for work in one of the 20 coastal counties. The second is it development, placement of a structure in the water would trigger, the development side of things. And then thirdly is the work in one of our areas of environmental concern. And in this photo on the first slide, you can see 4 of those areas, the upland side being the coastal shoreline, 75 feet landward of high water. You can see some coastal wetlands. Coastal wetlands are their own area of environmental concern. And then waterward of high water, we have estuarine waters and public trust area. Hey, it worked. You've seen a lot of photos. You've heard a lot about what living shorelines can do, ecosystem benefits, construction, all of these things. What we're looking for in a permit application is a material being proposed that's going to stay in place. It's free of pollutants. It doesn't have rebar in it. This is different pieces of rock and concrete in this photo. Any of those materials can be used, including oyster shell. In the beginning, gabion boxes were proposed. They're kind of small cages for these areas, and we have seen that those are probably not a good material. They don't tend to stay in place as well. So we're looking at riprap stone, including granite, marl, loose shell, oyster shell in bags, and then obviously broken concrete with rebar removed. The living shorelines themselves are placed offshore. Obviously, they're parallel to shore, with the idea of reducing wave energy. In this photo, you can see the existing grasses on the left, and then just landward of the living shoreline, you can see some planted grasses. And then that is the ecosystem enhancement being created behind it. And I'm going to show you a visual of these two different sill types, but for the beginning, I want to talk about the permits because it can be very confusing. General permits, which you're going to hear GP, are expedited permits. We can issue these within a couple weeks, but there's specific criteria addressed to them. And if those thresholds are exceeded, you end up applying for what's called a major permit. There are 10 state and 4 federal agencies that review permits for development. Under the general permit, these thresholds for criteria have already been agreed upon with these state and federal agencies. If you exceed those, they want to review the project themselves, and that can take 75 to 90 days. You will get a major permit issued from our central office in Morehead City if it exceeds the general permit thresholds, and I'll go through what those look like. We actually have two types of general permits. One really addresses wetland protection, and the second, wetland enhancement. The top is, Tracy showed an example in the field of this, wetland riprap revetment. This is actually for marsh protection that has an identifiable existing escarpment. It can't be more than 3 feet high. We're not trying to build a really large structure here, but the riprap is installed immediately waterward of the escarpment in this case. It can be up to 6 feet waterward depending on site conditions. These are meant to be low profile. They cannot be more than 6 inches above high water, and the maximum length under a general permit for these is 500 linear feet. So in some areas where you see heavy wake from boats, you can see sometimes an identifiable erosion escarpment just waterward of the wetlands, and this type of revetment can actually protect further erosion and further degradation and loss of wetlands. The second is the marsh sill, which we call the living shoreline general permit, and that is called a general permit 2700. And we've seen lots of different examples of these. The thing to note in this photo is that the oyster bag sill is placed waterward of the area we want to enhance. Planting can be done landward of this area, but if any type of fill is proposed at all, then you are automatically looking at a major permit review for that type of development. So the general permit is very, very specific. We've worked with the Corps of Engineers and all the other agencies to determine what could be permitted. Obviously, some of these things are going to be site specific, but these are the general criteria. You're limited to 30 feet past normal high water. So that's a big area where wetland enhancement can be done, or 5 feet past existing wetlands. So whichever is greater. You cannot exceed 12 inches above normal high water. So these are, higher than an actual revetment, but still meant to be relatively low profile. We talk about the slope because we want the material to stay in place. It cannot exceed 1.5 feet horizontal over a foot vertical rise. And the maximum length, again, just like a revetment, is 500 feet. So the design has to have 5-foot openings every 100 feet. This is allowing flushing and marine mammal movement. It's a requirement, and it will have to be in the design that's submitted. You can have a maximum base width of up to 12 feet. Navigational markers are required every 50 feet. It's different down here than in the northern part of the state. Our tidal range is 4 to 5 feet. So as you can imagine, under high tide, sometimes we have a full moon tide. These can be completely submerged, and we want clear navigational marking on those. You cannot construct a living shoreline over existing submerged aquatic vegetation or oyster beds. SAV was not super prevalent in New Hanover County, but now it is, especially in northern New Hanover County. SAV has been migrating south for some time. Sometimes if it's not the growing season, it's hard to tell. So we can help you coordinate with marine fisheries to determine if it's an area identified for habitat, and then look and see during the growing season if there is in fact SAV existing. Again, no associated backfill if you're applying for this expedited general permit. Any backfill will have to go through the major permit review, which takes the 75 to 90 days. We worked really hard to get a general permit. Everyone's been talking about living shorelines, promoting living shorelines. We want them to be available as a shoreline stabilization tool, but we had to work with the Corps of Engineers and other agencies in order to develop this. So finally, in March of 2019, the Corps came up with a regional permit that allows us to have a general permit to expedite these. So our general permit became effective in April 1st of 2019, which wasn't that long ago. I've probably only issued 4 or 5 myself. I've done a couple wetland revetments, but they're becoming more and more popular as more people hear about it. And I expect to doing more of this permitting in the near future. One thing that came out in discussions with the Corps is that these cannot interfere with navigation. Obviously, different tidal and wave energy environments are going to be compatible or incompatible with living shorelines, but access channels, deep water channels, access, egress to shellfish leases, all of these things need to be taken into consideration. So, for example, if there's an existing shellfish lease in the vicinity, we'd have notification to that shellfish lease holder, and then we would all coordinate to make sure they still had access and egress to that lease that they hold. So if you want to know all the specific criteria for a general permit, you can Google NCDCM, and it's the general permit 2700. It'll tell you the purpose, the approval procedures, and outline all of those individual criteria that I've talked about that allow you to qualify for this type of permit. It's relatively simple to get. We need a drawing. The drawing needs to show us, where are you in the world? Where's high water? Where are coastal wetlands? What's the water body that you're working within? Where are your property lines? Your property lines determine your riparian corridor in which you can do work. All of our general permits require adjacent property notification. It's part of the permit process. It just says, hey, I'm going to do some water dependent work next door, just so we can make sure if there's any objections, we can address them. If you're applying for a living shoreline and you're less than 25 feet below high water, you simply need to notify your adjacent property owners. If you're farther than 25 feet, we are going to need waivers from those adjacent property owners if you're going to be within 15 feet of those riparian lines. So if it's closer than 25 feet, we're looking at this similarly to a bulkhead construction, where you're going to be able to go all the way to your property boundaries or your riparian line boundaries. When it starts getting farther offshore, there's concerns of people being able to access their shoreline and their properties. So we do, in fact, want the adjacent property owners to be more involved and understand the project and waive it so that you can work in that area. This permit is $200. They're good for 4 months. They don't get renewed. Our general permits aren't a renewable permit. It's meant to be a development permit where you do work and then the work is complete. If they expire, you do have to obtain a new one, as their expiration date is just that. It isn't meant to be a renewed permit. I have lost my little up and down arrows.
Move your cursor over to this side and see if it pops back up. Or you can just,
there it is. Got it.
okay.
Well, thank you. For living shoreline proposals that don't meet the general permit, you have to go through what I call the major permit review process. Again, there's 10 state agencies, 4 federal agencies. They all provide comments back to our permit coordinator on your specific project. Some of their comments will be incorporated into some of the permit conditions that may be included. Again, this can average 75 days. There's a note that says it can be issued within 30 or 45 days. You can cross that out because right now permits are taking 75 to 90 days at least. The Corps of Engineers is very, very, very busy with permits coming in as we are, and things just aren't getting out as quickly right now with the number of projects that are coming in. This type of permit application is much more involved because of all of the reviewers that are looking at it. Again, you need your adjacent property notifications, but we're also going to ask for a deed and to show that the applicant does in fact have the riparian rights and the ability to apply for a permit. And our drawings have to be to scale. We're going to need a top view drawing and a cross section. We want to know where low water and high water are in relation to your proposal. And all of this in a sort of drawing that can conceptualize the project and the surrounding area. So there's a little more to it with the major permit. We have a form for these. MP1 is your general application form. And then you'll also fill out what's called excavation and fill, which is the MP2, which is going to ask you how much material you're putting in, where it's coming from, and length, width, things like that. This is a $400 permit fee, and that's because Division of Water Resources has to issue an authorization as well, and we actually split that fee with them. So here's an example of the major permit type drawings. This was the Carolina Beach living shoreline that they did at the state park. The one on the left shows, let me get a bigger version here so I can look at it, a little scale bar and legend in the bottom, and you can see where it says 1 inch equals 100 feet. It's dated, it's sheet 3 of 3, and that's your legend. We're going to need the project name and everything. And then you actually scale out the project. They did this using an aerial, but it still scales out, and you can see where they're proposing the gaps in the wall, and you can see that they're calling this an oyster bag sill. On the right is the cross-section view, and it's showing us all of the things we need to know, where the marsh is, where the high ground is, where our proposed planting area is, and where our proposed sill is, along with the base width, and that'll be relative to normal high water, or if it's surveyed, mean high water. So there isn't any fill proposed with this one, so why was this a major permit? Well, if you look at the drawing to the left, you'll see that the oyster bag sill is 610 linear feet. That's beyond the 500-foot threshold for a general permit, so it had to go through major permit review. Quick tips for expedited applications. Some of this we can help you with in the field. Field reps will meet you on site, do a field appointment, make sure your project meets the applicable permit type, and can help you with some of this. If you do some of this review before you apply, things might happen a little bit faster. The first is to discuss navigational impacts. Are you adjacent to a deep water channel or even a shallow water channel that's the only access to the area? Are you going to block any access? Are you adjacent to shellfish? Things like that. Go ahead and propose markers and reflectors and have that on the proposal because they're going to be required. Something that can take a while, especially if you're in northern New Hanover, Pender County, is reviewing possible SAV impacts. We've had quite a few projects this year where the proposal was within an identified habitat, but it wasn't the growing season. So we didn't know exactly where that SAV was. And a lot of times fisheries wants to wait till the growing season to figure that out so that we can avoid those areas. You want to discuss oyster growing potential if that's the material you're going to use. Obviously, habitat enhancement, increased water quality, increased oyster growth, all these things are environmental benefits. And some of the reviewing agencies are North Carolina Fish and Wildlife, Division of Marine Fisheries, agencies that are looking at these resources. You can determine if the area is currently open or closed to shellfish. And maybe your oyster sill is going to be something that could enhance an area. And if it's provisionally closed, maybe it would help an area become open again one day if it's large enough. There's a lot of things that we have to research to put in our reports, but some of this information in your project narrative will help the resource agencies review your project faster. You want to determine your bottom type, mud or sand. Different materials are going to work better with different environments. We don't design projects, but we can sure tell you, based on experience in the proposal, what seems to be working and if your material is going to be able to be utilized or not. If your material is really small and it's going to be subject to wave or tidal action, it might move on site. We're going to let you know that we need to use larger material, things like that. You absolutely want to propose gaps for marine animal movement. Again, that's 5-foot gaps for every 100 feet. These are meant to be living environments to encompass what's already there. Living shoreline, they're called that for a reason. We're looking at ecosystem benefits. We're creating wetland areas while reducing wave action and erosion. So lots of things to consider, and some of these are going to be required by regulation. That's permitting in a nutshell. Permitting is a lot more than that, but those are the things we need from the applicant in order to review a project. And then we will meet you on site. And that's the beauty of this process is we go to every single site we issue a permit for. We look at it, we're on the ground, and we understand what exactly is being proposed. In this photo here, you can see that the environment behind this sill, I mean, it's a calm day, but if it wasn't and it was windy and there were waves, the environment behind is more protected. So wetland growth isn't going to scour out. And this is kind of a combo project where there was living shoreline put offshore, but then some of the end of the sill was actually right in front of wetlands. And this was to create the wetland environment that was once there. I've seen quite a few of the ones that Coastal Federation has done using different materials. It's really cool to watch it change over time. Smaller property owner projects that have been done, we'll let you know if you're getting wave action from a ferry or large boats, this probably isn't going to create the sort of erosion waiver that you're looking for. Like the backside of St. James, if you know that area adjacent to the waterway, they use breakwaters there because they get a lot of wave action up and down the waterway. But projects along tidal creeks or lower wave energy, these tend to work really well. I'm speaking from an environment that has a 4 to 5 foot tidal range. So, our tides can be astronomically different. Up north where it's a lot less, these probably work better in a lot of areas that are lower energy. But if you guys have proposals and you do have questions, we will meet with you. We can look at the project and help you design it so that it does meet the permitting regulations. And if anyone has any specific questions, I'm happy to take them.
Hey, Tara, it's Adam. How are you?
Hey, how are you?
Doing good, doing good. I'm just curious. I mean, you didn't mention it, but are there any kind of like monitoring that needs to be done of these projects once they're constructed, or like a 1-year site visit to kind of see how things are going from the permitting or regulatory standpoint?
Not by rule on the general permits, except the revetments, the ones that are put on an erosion escarpment right adjacent to a wetland area. If those are not maintained, they will be requested to be removed. For the living shoreline, there's nothing required. However, we like to go back and see how they're doing. And sometimes people come in to do maintenance work to them, and we'll come back out and look at it again. The major permits sometimes have monitoring requirements on them because those will come from some of the resource agencies.
Okay, yeah, no, I'm just curious, and you mentioned the maintenance as well, and I'm curious if that's the homeowner, or I know Tracy had spoke about, or someone in the last one, of having a contractor maybe do annual visits to perform maintenance, or something after storms to go make sure everything is still looking all right. But just curious
And
about
that
that.
is a very good idea post-storm. If it's less than 50% of that, we're going to allow maintenance and repair to keep these functioning as they should. Absolutely. Post-storm, most of these are visited by either the property owner or the contractor. And I've done a couple exemptions for repair on them. We don't have a requirement. The reserve did a giant project looking at some of these across the coast and monitored them for a couple years. I don't believe that program's still running.
And I'll just add to that, Adam, there's a section next week on monitoring and maintenance, kind of things to look for, and also business opportunities to engage property owners in that. So,
Okay,
Adam,
great.
I'll add as well, the biggest issue is whether you're growing the marsh grasses or not. That these structures are intentionally sized very small to barely protect the marshes behind them, but create an environment that they can flourish. That if you can't grow the marsh, they generally don't solve the erosion problems at all. So if you're not successful in the initial planning, you definitely need to go back in and get your foot in the door to get the native marsh grasses spreading.
And sometimes that's an elevation change, and sometimes you need to bring in clean sand material to get the substrate right. As most of us know, coastal wetlands are very sensitive to elevation, and if that elevation changes, the plant community changes. So sometimes that fill element, is really part of a project, as it's not going to work without it, and then that'll elevate it to the major permit. But if that's what makes the project work, that's what you're going to need to do.
No, that's great information. And I just want to kind of point out, from the comparison of a bulkhead where you build it and it's there, and there will be some maintenance probably over some years, but where you have a living shoreline structure, a sill, or that marsh tow revetment, that there is some kind of watching that needs to be done to make sure that things are working, and that you are getting that suitable environment behind that to make sure that the plants, the marsh plants are growing and are successful.
Yeah, and that material can move, especially if there's a storm. The bulkhead issue is it's going to scour out in front of your bulkhead. Happens every time, especially in high wave energy environments. And that's going to take the coastal wetlands out because elevation is going to change. There's definitely criteria, and we've heard a lot about it, where different things work best. But if there's ever been a storm or a nor'easter, I would absolutely expect someone to look at this area. If they've, paid to install it and done all the work, that they'd want to make sure it was still functioning.
Adam, any structure is likely to take some maintenance in the long run, but these structures in major storms get submerged so quickly that they actually have less damage in the major storms than higher elevation structures like bulkheads and revetments farther up the upland property. But one of the structures that was accidentally constructed is on Ocracoke Island near the ferry parking area. It's been in place since 1962 with no maintenance whatsoever. So certainly any structure needs to get a check after storms and from year to year, but these aren't necessarily higher maintenance structures than bulkheads and other higher ground elevations.
Tara, could you speak to, just for folks on the call, because I mentioned vertical wall sills that are also qualify in many cases for the general permit. I think they're called vertical wall bulkheads or breakwaters.
Breakwaters, yeah.
I just mentioned that. And I think the St. James one, we work with them on that. I would qualify that project as a living shoreline. And I can't remember whether it's been done in phases, whether it qualified for that GP or not, but it's basically a vertical wall sill channelward of restored marsh. But
yeah, and unfortunately, a lot of those are not in good shape anymore. I've looked at a bunch of them, and some of the newer property owners that are coming in don't know our environment, and they're taking them out. and they don't know that that's why there's marsh out there.
That's unfortunate.
Yeah, so that's called the general permit for a sheet pile sill. And that's because you're using vertical sheets. You know, it's different material. And this is, the breakwaters have been around for quite a while. They still require gaps and things like that. But if there's a higher wave environment, that structure is probably going to hold up better, and you're still going to get wetland enhancement behind it.
So I just want folks to know that we've got a demonstration project going in Topsail Beach, and the contractor does these vertical wall sills, and he's telling me that he has a great, you know, he's using this GP regularly, and it takes less than a week to get it.
Yep.
And I just want to say that our relationship with the DCM folks and others on this has been really, really good, especially as everyone's comfort increases in these. So it has not been a disincentive for their use, which is fantastic.
Yeah, and we've had a work group Whitney and I have been involved in for a couple of years now as this developed over time, creating these thresholds, looking at the criteria, working with the Corps, finding ways to get these available as a general permit so that they're easier to use, because we absolutely understand the benefits.
Hey, Tara, it's Greg.
Hey.
Hey, for the GP 2700, you
Mhm.
said, you know, they could not be built, the sills couldn't be built over SAV and oyster beds. But what if you're, you know, adding the bags or enhancing existing oyster
Well,
beds?
you wouldn't be able to fill them. You don't want to lose habitat to create different habitat. We want to keep the habitat that's there. So if there's SAV in an area, that would probably get elevated to a major permit so that the other agencies could review that specific site and do what would be best for the resource.
Right, but if it's oyster beds, you said you couldn't, could you not enhance an
You
existing
can
oyster bed?
enhance, you can't fill, but so if you're putting in, it depends on the material, but you can't fill something that is already productive, that's already functioning, because then we're changing that function. There's a way to enhance it, absolutely.
Okay.
You're on mute, Tracy.
I was going to say, in many cases, we might have a patch of oyster reef within the alignment that we want to establish, and we just tie into it on both sides. So you don't need to fill it if it's already functioning. So yeah, but you know, and as far as the SAV goes, we are looking for that now. Oftentimes we're able to design so that we're still landward of that SAV. And that's really important, because what we know about productivity and fish usage, et cetera, is that they're really, the fish are happiest when they can interact between the SAV and the coastal marshes. So